Welcome to a new video. Today we are going to talk about math library of Python. The Python math library comes pre-installed with Python, so you don't need to install it separately. Normally, if you want to use a library, you make pip install or you install locally, but with math library we don't need that. Math library provides a wide range of mathematical functions, constants and operations. And we are going to import the math library right now, and we are going to discover what are them. So after importing it, we can access to its functionalities. For example, let's say we want to get the pi. So here it is. And there we have it, the values of pi up to several decimal places. First up, we have some basic arithmetic functions like power and square root. Let's say we want to get the power of 3. So 2 to the power of 3 is 8. So we can also do this like print. We can use f string and we can say 2 to the power of 3 is, and after that we can say math.power 2 and 3. Great. It returns as float. You can just change it to integer for not seeing the digit, and we are going to make this decimal disappear like this. For calculating the square root, we will say math.square root, and let's give 16 for getting the 4. Also, it returns as float, like you can just check the type of the data that returns. You can just make it integer, like you can just make the decimal disappear like this. If you want to get the absolute value, we can use the fabs function. So we will say fabs, and we are just going to give the -10 for getting the 10. Also, you can just change the data type if you don't want decimal. And we are going to, so the absolute value of -10 is 10. Great. Let's move on to trigonometric functions. We have sine, cosine, and tangent. These functions expect angles in radians, not degrees. So let's take a look at that. So let's use .sin method to get sine of an angle. So we will say math.sin, and we will say math.radians 30. So it's 0.499994. What you can do in here for taking it as 0.5 is you can just use the round function, and you can give 2 after this, and when you run this one you are going to see 0.5 in here. Also, you can just change this like 3, 4, and it's going to be the same. Okay, now let's use the cos to get the cosine of an angle. So we will say math.cos, math.radians, and we will give the 60 in here. Great. Also, you can use round in here again. We can use 10 to get the tangent of an angle. So we can say math.10, and we can just say math.radians. Let's get the 45. So you can just use round again if you want to get the 1. And you can just say like this, and after that you will see you get the 1. Also, you can just change this to integer for not getting the decimal. It's up to you. Okay, let's talk about the logarithms. Logarithmic functions are crucial in various fields, and we use them a lot. So let's explore log base 10 and log base 2. So what we are going to do is, firstly, let's get the natural logarithm of e. So we will say math.logarithm, and we will say 2.71, and let me quickly check and re-record again. I remember it like 8. Yes, I remember it correctly. We will say 828 after that, and here it is. So here the natural logarithm of e is close to 1. Great. Let's use the others. So we will say math.logarithm 10, and after that we will say 100. So here it is, it's 2. And after that let's use math.logarithm 2, 8. We are going to get the result of 3 in here. Also, you can manipulate these answers, like again, you can just add integer after that for not getting the decimal. Great. So math.logarithm 10 and math.logarithm 2 gives you logarithms with base 10 and base 2 respectively. As you can see, the log base 10 of 100 is 2 and the log base 2 of 8 is 3. Sometimes you may want to round numbers up or down. The math library provides cell, floor, and round functions for this. So let's write them and talk about them. So I will say math.sail 4.1 and I will say math.floor and I will say 4.9. So let's talk about them. Math.sail rounds up and math.floor rounds down. So the ceiling of 4.1 is 5 and the floor of 4.9 is 4. Let's talk about hyperbolic functions. Hyperbolic functions, like their trigonometric counterparts, are useful in various calculations, including complex numbers and waveforms. So that's why I want to include them also in this tutorial. Let's see how to use sine h, cosine h and tangent h. This h will represent the hyperbolic in there. So we will say math.sin h and we will say 1. So we got the hyperbolic sine of 1 as 1.17. So we can also use this for others like math.cos h1 and we get that. And also we can do the same for the tangent like tan h1 and it's 0.76. Great. Okay, now let's explore some combinatorial functions such as factorial and for combinations. These are essential in probability theory, statistics, and even in machine learning. So let's get the factorial of 5 like math.factorial and we will say 5. So it's going to be 120. Also, we didn't talk about it. You can change the type to float if you want a decimal as 0. So you can just throw the float in here and you can get decimal if you want to work with decimals. So here it is. We talked about the integer part, but we didn't talk about the float part before this. Okay, that factorial calculates the factorial of given integer. As you can see, 5 factorial is 120. So if you give 6 in here, it's going to be 720. Okay, let's see the combination side. We will say math.comb and I will give the 5, 2. So this is like number of ways to choose 2 items from 5 and it's going to be 10. Great, let's talk about error and gamma functions. Error and gamma functions are vital in statistics, physics, and engineering. Python's math library offers error function and gamma for these calculations. So we will say math.erf1 in here for calculating the error function of 1. Also, we have complementary error function in here, like you can just add c after the end of the ERF and let's give it 1 in here and here it is, the complementary of it. So what you can do is for finding the 1, you can say math.error function 1 plus, actually I need to reset this, math.error function complementary 1, it's going to be 1 like this. So let's also use the gamma function like math.gamma 5 and here it is 24. Okay, for the ending of this video, let's talk about the constants we have. I'm going to show you 2 more different than pi. Remember, we can reach the pi from math.pi and so let's get the value of e, which we can also refer as Euler's number. We can just call .e and we can get tau like this. It's approximately 6.28. Great! We have covered a lot today from the math library, from basic arithmetic to trigonometry, hyperbolic functions, and even some statistical and combinatorial functions. That was all for this video. Thanks for watching. I'm creating content about data science and programming. You can subscribe for my channel for more tutorials like this. Have a great day. Thanks for watching again.